Hello viewers, in today's class we'll see a very interesting problem, right? And this problem is going to be a very easy one, but here the main thing is that we'll see the power of derivatives, right? So here we'll see the power of calculus, right? So here we have to prove this expression and the well-known result from inverse trigonometric functions, that is sine inverse x plus cos inverse x is equal to pi by 2 using derivatives, right? So in this lecture we'll see how we can derive this result by using the concept of derivatives, right? So let us start. Now see, here we have sine inverse x plus cos inverse x in the left hand side and pi by 2 in the right hand side, right? So let us take this function as f of x, right? So we'll assume this function as sine inverse x plus cos inverse x, right? Now let us differentiate f of x with respect to x, right? That is, let us find f prime of x, that is df over dx. So here we have f prime of x, right? So we have d by dx of sine inverse x plus cos inverse x, right? Now from calculus we know that the derivative of sine inverse x is 1 over square root of 1 minus x square, and the derivative of cos inverse x is minus 1 over square root of 1 minus x square, right? So now we see that both these terms are equal but opposite, so these two terms get cancelled and we are left with 0, right? So now we have obtained this equation, that is f prime of x is equal to 0. So we see that the derivative of f of x is equal to 0, right? And f prime of x is equal to 0 is a differential equation, right? So we have df over dx is equal to 0, right? And moreover, we know that the derivative of a constant function is 0, right? And see, in the result we have sine inverse x plus cos inverse x is equal to pi by 2, and pi by 2 is a constant, right? And this is also evident from this result, that is f prime of x is equal to 0, right? So now we have f prime of x is equal to 0. So now if we integrate both sides, right, if we integrate both sides with respect to x, then we'll get df over dx here, and here we have 0, so here we have a constant, right? So now we have f is equal to c, right? So the integral of df over dx with respect to dx is f, and f is equal to c, right? So here f prime of x is equal to 0, so it means the function must be a constant function where c is some constant, right? So now we have f of x is equal to c, and our aim is to find out the value of c. So now to get the value of this constant c, let us take x is equal to say 0, right? So when we take x is equal to 0, from here we get f of 0 is equal to c, right? And if we take x is equal to 0 in this function, then f of 0 is equal to sine inverse 0 plus cos inverse 0, right? And sine inverse 0 is 0, cos inverse 0 is equal to pi by 2, right? Because cos pi by 2 is equal to 0, right? So pi by 2 is equal to cos inverse 0. So here we have 0 plus pi by 2. So this is pi by 2, right? So we have obtained f of 0 is equal to pi by 2. So now we can substitute f of 0 is equal to pi by 2 over here. So we get c is equal to pi by 2, right? And when we take c is equal to pi by 2 in this equation, then we can get f of x is equal to pi by 2, and f of x is sine inverse x plus cos inverse x, that is equal to pi by 2, right? So this is how we can prove this important result from inverse trigonometric functions. Now viewers, here I would like to mention an important point, right? See, here we have assumed that x is equal to 0, right? Suppose if we take some other value, say x is equal to half, right? So here we'll take some convenient value so that we can find out the corresponding angle, right? So if we take x is equal to half, then see here f of half, that is from f of x is equal to c, we can write f of half is equal to c, right? So if we take x is equal to half instead of x is equal to 0, then we'll show that we'll get the same value of c as pi by 2, right? So when x is half, so f of half is equal to c. And now let us find out the value of f of half from this equation, right? So f of half is equal to sine inverse half plus cos inverse half, right? Now sine inverse half is pi by 6, and here cos inverse of half is equal to pi by 3, right? Now if we add and we take the LCM of 6 and 3, will get 6, and then here we'll get pi, and here we get 2 pi. So this is 3 pi over 6, right? So this is equal to pi over 2, right? So again, we get here the value of c as half, because f of half is equal to pi by 2, right? So again, c is equal to pi by 2, and we'll get the same result, right? So we can take different values of x, and every time we'll get the same value of c as pi by 2.